Hello everyone. This video is about truncated tetrahedron. So in this video, I'm going to give the exact meaning of truncated tetrahedron, how truncated tetrahedron is produced, and how to compare the different parameters of a tetrahedron and truncated tetrahedron. So here you can see the two objects. One is a tetrahedron, another one is a truncated tetrahedron. First, if you see this tetrahedron, the name of uh, this tetrahedron is given based on number of faces. If you see, it has totally four triangular faces. So here, this is the first triangular face, this is the second triangular face, and at the bottom there is one triangular face, and at the back side of this also there is one triangular face. Totally the tetrahedron has four triangular faces. Since it has four faces, the name was given like a tetrahedron. Now the topic is about a truncated tetrahedron. So first, what is the exact meaning of truncated tetrahedron? How can we convert this tetrahedron into truncated tetrahedron? What are the different parameters like number of edges, number of corners, and number of faces in tetrahedron and truncated tetrahedron? How to compare and how to count? That's what we are going to learn. So the exact meaning of a truncated tetrahedron. So this is a polyhedron which is produced due to cutting of corners of normal tetrahedron. So first you have to take a normal tetrahedron. If you cut this normal tetrahedron through the corners, that is going to be converted to truncated tetrahedron. So this is the exact definition. So a truncated tetrahedron is a polyhedron created by truncating the vertices of a regular tetrahedron. So first let us take a regular tetrahedron, and in this picture you can see a regular tetrahedron which has totally four corners. You can see here, this is the first one, this is the second one, this is the third one, and this is the fourth one. So it has a regular tetrahedron, it has the four corners. So the number of corners possessed by regular tetrahedron, so that is the four corners. And if you see the number of edges, if you see the number of edges, you can see here, this is the first one, this is the second one, this is the third one, this is the fourth one, this is the fifth one. In fact, sixth one is not visible in this picture, that is between these two. So totally the number of edges in regular tetrahedron, that number is 6. And if you see the faces, if you see the faces, it has four triangular faces. So here, this is the first triangular face, and this is the second triangular face, and at the base one triangular face, and the back side of this one triangular face. So totally there are four triangular faces, four faces. But the name tetrahedron, so it is a polyhedron with the four faces. That tetra indicates a four. So it is just a coincidence. Corners number is also four, faces number is also four. But here the name tetrahedron, that is based on number of faces. Now the discussion is how truncated tetrahedron is produced, and how to count, how to calculate the number of corners, edges, and faces. How many types of faces it is going to get? That's what we are going to discuss in this. So already I told you the definition of truncated tetrahedron. You have to cut this normal tetrahedron through the corners. So whenever you cut the normal tetrahedron through the corners, you can see this is the corner of a regular tetrahedron. This corner is connecting three edges. As a result, whenever it is truncated like this, at this corner you are going to get a triangular face. At the corner of regular tetrahedron, due to the truncation, you are going to get a triangular face. And this triangular face has three corners. That means Here we are going to get totally 3 corners because you are just truncating this. As a result, the corner of regular tetrahedron is going to become a triangular face. That triangular face contains 3 corners. As a result, so totally 4 corners are present in a regular tetrahedron. At each corner, one triangular face is produced. Each triangular face has 3 corners. That means 3 into each triangular face has 3 corners. 3 into such triangular faces are totally 4. So 3 into 4, 3 into 4, that is 12 corners you are going to get in truncated tetrahedron. So you can see two triangular faces can be seen in this picture. So here this is one triangular face, and like this here also one triangular face will be produced. Here also one triangular face will be produced. As a result, truncated tetrahedron will have totally 12 corners. So the number of corners in truncated tetrahedron, that is 12. And now let us calculate the number of edges. And if you see, due to the same thing, that is a truncation, here one triangular face is produced. So this triangular face is having 3 edges. So here already regular tetrahedron has 6 edges, and due to truncation, at the corner of regular tetrahedron, one triangular face is produced, and each triangular face has 3 edges. So here 4 such triangular faces are produced, and each one is having 3 triangular faces. Therefore, that is 4 into 3. So here these are the original edges, and these are the new edges produced. So here I am writing 4 into 3. Here I am writing 4 into 3. So here 4 triangular faces are produced, and each triangular face contains 3 edges. As a result, so here 4 into 3, that is 12 newly formed edges, and 6 original edges. Totally it is going to have 18 edges. So the number of edges in truncated tetrahedron will be 18. And one more parameter we have to compare, that is number of faces. You already know in regular tetrahedron there are 4 triangular faces, and due to those 4 triangular faces, what they are going to become, if you observe. So here due to the truncation, here one edge is produced, here one edge is produced, here one edge is produced. As a result, whatever the triangular face you had, that is going to become hexagonal face. You can see, so after truncation, you can see the original triangular face is going to become hexagonal face, because you can see here this face has 6 corners, and this is a hexagonal face. So each triangular face is going to become what do we call a hexagonal face. So that is 4 hexagonal faces, 4 hexagonal faces. And due to the truncation, one triangular face is produced at the corner of regular tetrahedron, and that triangular face, you can see 4 such faces will be present, because each triangular face will be present at the corner of regular tetrahedron. Regular tetrahedron has 4 corners. Each corner of regular tetrahedron is going to have one triangular face. Therefore, 4 hexagonal faces plus 4 triangular faces, 4 triangular faces. As a result, the number of faces will be 8. So this is the final comparison of a truncated tetrahedron and tetrahedron. The exact meaning of tetrahedron, exact meaning of truncated tetrahedron, and the comparison of various parameters, number of corners, number of edges, and a number of faces. It is very difficult to remember the values. Only you have to visualize the object. You have to know the exact meaning of truncation, and due to truncation, how new faces are produced, how new edges are produced, and how new corners are produced. So thank you very much.